This next rule is going to tell us that when we have the sum of two derivatives, we can take the derivatives of each of those functions and add them together. So it's called the derivative sum rule. And it says the derivative of f of x plus g of x is equal to f prime of x plus g prime of x. Okay, so it just kind of says if you're adding two functions, you can take the derivative of each of them independently. And this, with our other rules, will actually allow us to take the derivative of any polynomial very easily, and lots of other functions. So let's have this new function. Let's call h of x. H is a bad letter. Let's call s of x, s for sum. We'll let it be f of x plus g of x. And what we want to show that s prime of x is equal to f prime of x plus g prime of x. Okay, so we know that the rule is that s prime of x is equal to the limit as h goes to 0 of s of x plus h minus s of x all over h. So filling this in, we've got the limit as h goes to 0. S of x plus h is going to be f of x plus h plus g of x plus h minus s of x, so that'll be f of x plus g of x all over h. The first thing I'm going to do is distribute that negative sign that's on our second term in our numerator. So this is equal to the limit as h goes to 0 of f of x plus h plus g of x plus h minus f of x minus g of x all over h. And now we're going to do a little bit of rearranging. We're going to rewrite this as the limit. We're going to put the f's together and the g's together. So we'd have f of x plus h minus f of x plus g of x plus h minus g of x. And as long as we keep the sign that's with them, we can rearrange the addition. It's called the commutative property of addition. And now we can actually break this into two fractions with the same denominator. So this is equal to the limit, h goes to 0. And just to be precise, we're going to put parentheses around this. So it would be f of x plus h minus f of x over h plus g of x plus h minus g of x over h. So we've kind of split that into two pieces. And one of our limit rules was that if you were adding two things, you could write it as two limits. So we can write this as the limit as h goes to 0. It's kind of like distributing the limit, but not really. We're just saying we have two things that we're adding together. We can add their two limits. And hopefully by now you kind of see where this is going. We're now going to have two limits that are exactly the derivative of f. This first one's the derivative of f plus the second limit is now the derivative of g. So we can now say that this first piece, this, is equal to f prime of x plus the second piece is equal to g prime of x. So we have shown that s prime of x is equal to f prime of x plus g prime of x. Okay, so what this is saying is if you're adding or subtracting things, you can take the derivative of each piece. So here, the first one we want to look at is f of x equals 3x squared plus 5x. So we're going to take the derivative of 3x squared. So we take 2 times 3, which is 6x. We would subtract 1 from the squared, so we just get x to the first power. Plus 5x, well, think of this like 5x to the first power. We'd have 1 times 5 is 5. X to 1 minus 1 is 0. And this isn't something we've talked about yet, but we should have. This x to the 0th power, well, anything to the 0th power is just equal to 1. So this is equal to 6x plus 5 as our derivative. Okay, next we want to look at g of x equals 19x cubed plus 5 over x to the 9th plus 7. And the first thing I like to do before I take any derivatives is make everything look like powers of x. So this 5x to the ninth, I'm going to write that as 5x to the negative ninth plus 7. So now we're going to take the derivative of each of these pieces. So g prime of x, we're going to do 19 times 3, which is 57. So 57, we subtract the power, so x squared. Now we do negative 9 times 5, so that'll give us negative 45. X, negative 9 minus 1 is negative 10. Now we've got the derivative of 7, which that's just a constant, and we've talked about how the derivative of constants is 0. So it really just goes away. We'd say plus 0 here, but we know adding 0 doesn't change anything. So the most simplified version of this would be 57x squared minus, we'd do 45 over x to the 10th because of the negative 10. Plus 0, which is just nothing. So here's our derivative. In our last one here, we have pi x plus the square root of x. So again, before I take the derivative, I'm going to write this as pi x plus x to the 1/2. So the derivative here, well, pi times x, remember, like, this is x to the first, so 1 times pi, and then we get x to the 0, which is just 1. So we just get pi plus, now when we take the derivative of x to the 1/2, it'll be 1/2 x to the negative 1/2. And the most simplified version of this would be pi plus 1 over 2 square root of x.